So here is the first step of our position estimation and 3D reconstruction program, the DL pipeline required to extract these features such as the position of a vehicle. We'll be using depth anything v2 and YOLO 11 Neo for our task. First, we'll define a bunch of assumed constants, just a couple around here, and we'll also be using MongoDB to hold our data so that the environment reconstructor and the data analysis agents can do their job. Our approach is that there can be at most 3 to 4 cases in any given video. Either there are 0 detectables, 1 detectable, 2 detectables, or more than 2 detectables. Now, in the case of 0 detectables, it's trivial what we'll do. In case of 1 detectable, what we can do is, given that it is above our confidence interval, above our confidence threshold, we can easily calculate the distance to it using basic mathematics. Since there's only one detectable, there's not a lot of noise or anything else on screen. For two detectables, we can calculate the distances to both of these objects using basic mathematics. But for more than two objects, what we can do is generate a depth map using depth anything v2 and calculate the distances to our two most confidently detected objects and get a linear model placed on them, so that I map the relative depth produced by depth anything v2 to a real distance using these already two calculated absolute distances. Now that that is done, we'll also be sending all this data concurrently per frame to MongoDB for data analysis. We'll be reading each frame as is. We'll be reading them at 3 to 5 FPS, since that's all that's required even for like a high speed car, which we do not expect FSDs to be going at. And for traffic cameras, since they cover a lot more area using their lenses and their high altitude, like high vantage points, we don't even need 3 fps, we can switch to 1 fps. Now here are a couple of results of this running. Here's just one car direct distance calculation, just a one car direct distance calculation. Let me scroll all the way to a frame where we'll have multiple cars. Here it's detecting 3 vehicles at once and it's giving fairly accurate approximate positions. X being negative means it's to the left of the camera. X being positive means it's to the right of the camera by however many meters. Uh, it's giving fairly accurate distance measurements too. And then it goes back to detecting all of them. It's giving fairly accurate distance measurements using our depth map technology. Now, the good thing about all of this and the good thing about using MongoDB is our data analysis agent. What it will do is it will connect to MongoDB Atlas and immediately do a bunch of data analysis on it, like cars per frame or smooth car counts per frame, the average pairwise distance between per frame between each pair of cars, or the heat map of vehicle positions. In this case, it looks like this because the driver was driving on the right lane of the road, so the left lane will usually be occupied, and the occasional points on the right are due to the oncoming traffic.